Hey guys, Mr. Mars here. Forgive the voice. I told you there was going to be an issue, but hey, we'll deal with it. We'll get through it. Okay. So today we're talking about the similar triangle applications. So what that means is we're going to actually take what we've learned about similar triangles. We're going to apply them to actual real life situations that may take place or situations that you might see come in a test or on a EOC or something like that. So the four things we need to do are right here. Here are your four steps. Okay. And I know sometimes, you're like, oh, can I skip a step? You really don't want to skip a step. You want to do each of these each time. If you do that, these will be very simple problems. You'll get them set up and you won't have any issues. If you try and jump out on your own, you're going to run into some issues, okay? So here we go. First, we're going to draw a picture. If there's not a picture, we draw one. We talked about that all year long. Always draw a picture with these word problems. Two, we're going to label the sides. Whatever information they give us, we're going to go through and label the picture with everything that we have. Three, we're going to set up our proportion. The reason we say proportion is because with similar triangles, everything's about proportions, as we've been talking about. And then we're going to solve. We do our cross multiply, the butterfly, if you would, and we're going to solve for our proportion, okay? I may be sneaking over and using the calculator, so you have to bear with me if I do that. Make sure you take the notes. If you need to pause, you can pause. If you need to back up, you can back up. I'm going to go pretty slow and steady, but again, if you need to, you can back up. All right, so here we go. Move this up a little bit. So our first one says a 70-foot tall building casts a shadow that is 85 feet, period. So I'm going to do that. So I'm going to draw my building. Here's my building. Here's the shadow along the bottom, right? Here's my shadow down here, okay? It tells us that the building is 70 feet tall, and it tells us that the shadow down here along the bottom is 85 feet long for our shadow. Now, if it's casting a shadow, that means the sunshine is up here. Here's our sun. It's coming down like this. And that's where the rays are hitting, and that's making our shadow. Now, unless we have a really poorly built building, okay, we know that this angle right here is 90 degrees, right? Because buildings hit at 90 degrees. So we have ourselves a right triangle right here. This is 70, this is 85. This is my side coming down over here. It says at the same time of day, a 5-foot woman stands near the building. How long is her shadow? So the 5-foot tall woman is going to be standing, we'll say right here, right? Here she is right here, right? Here's her head. And that, I need to go make her a little bit taller here. So let me fix her so she's a little bit taller. She's going to have a long neck. There we go. Okay, it's a goofy looking person. Don't judge, right? She is 5 foot tall. So right here's where she is. Now, she's also standing at 90 degrees. This means these two are parallel, right? And I won't go through this every single time, but I need to be sure you understand. So those two are parallel, which means that this angle right here and this angle right here are the same. So the triangle for the person, the big triangle for the building, those are similar triangles, which means their sides have to be proportional, okay? They want to know, what is this distance right here? What is her shadow, okay? So we're going to compare, we're going to set up our proportion. That was step number 3. We're going to set up our proportion. I'm going to set mine up like this. I'm going to take anything that has to do with the building, for me, is going to go on top. Anything that has to do with the woman is going to go on the bottom, okay? And we have to pair up parts with parts. So I'm going to go building shadow, 85. Woman shadow, I don't know. Building shadow, building's height, 70. Woman's height, 5. Now you could have done it differently. For example, I could have decided that I want to put shadows on top and heights on bottom. If I did that, I'm not going to do it multiple times every time. So that way we'd be here forever. But if I do shadows over heights, then I could go building shadow, 85, building's height, 70. Woman's shadow, I don't know, woman's height, 5. In both cases, if you'll notice, when we cross multiply to solve, I'm taking the 85 times the 5 and the 70 times x. And I'm going to 85 times the 5 and the 70 times x, okay? So I'm going to go ahead and set that up and cross multiply those. So I'm going to go 70 times x has to equal 85 times 5. Now if I take 85 times 5, I get 425. If I divide that by 70, I get x equals a whopping 6.1 when I round it. And you'll notice that in the directions I'll leave it up there, it said round to the nearest tenth. If it didn't, we're going to round everything to the nearest tenths place, so 1 decimal place. Okay? Now, again, make sure that your notes look exactly like mine. Okay? I set up both of them, you set up both of them. Okay? All right, so that's our first one. Moving on to the second one. They have the picture for us. We just need to do the labeling. So it says a 10-foot tall tree. So this is our tree, right here, 10 foot tall. So we're going to put over here, this is our tree. Casts a shadow that is 22 feet long. So 22 feet long. J is standing 7 feet from the tree. So here's this. This is J. He's standing 7 feet from here to here. That's 7 feet. How tall is J? Well, we're looking for this measurement right here. If you look, we have shadow of tree. Oops, didn't mean to do that. We have shadow of tree, right? Height of tree, and we have shadow of tree. We have, what we're looking for is the height of J. Well, that means I need the shadow of J. Do we know that? Well, actually we do. We can come in here and say, okay, well, the tree shadow was 22. J shadow, this is tree. J shadow, we don't know, but the leftover is 7. So you got 7 here, and then we did this measurement, the whole length is 22. So if I take 22, subtract 7, I get 15. Oh, nice little glitch. So J's shadow is 15. We now have enough to set up our proportion. So I'm only going to do this once. I'm going to go tree to J. Tree's height, 10. J's height, I don't know. Tree shadow, 22. J shadow, 15. That was the distance from J over. We cross multiply. I get 22x equals 300 and, oh, I'm sorry. Yeah, 22x, I'm sorry, equals 150. Otherwise, I'm going to get 300. 22x equals 150. Divide by 22. And I get x equals 6.8 feet long. And that is J's height. Now, just so we're all on the same page, by the way, if the question asks you how tall is J, all right, 6.8 is not 6.8 feet. That's 6 8/10. So you'd have to find 8/10 of 12, which would actually be 6 foot 9 inches. Okay. I know you're disappointed it wasn't 6'7", but it's 6 feet 9 inches. Actually, a little bit more than 6 feet 9 inches. Okay. Next one, we have go till we get to dust till we see a period. Triangle ABC is similar to triangle DEF. All right, so here I'm going to draw a triangle ABC. I'm going to draw a triangle DEF. A, B, C, D, E, F. Now, I don't know which triangle is bigger. I'm just making DEF a little bit smaller. I don't know if that's going to be the case or not. Okay, triangle ABC has sides that are 3, 5, and 7. 3 being the smallest, 5 is the middle, 7 is the biggest. So I'm going to go, this is the small, this is the middle, this is the biggest. Now, I didn't say they were right triangles, even though mine may look like that, but that's fine. They're not right triangles. Okay? Triangle DEF has sides that are 7.5, 12.5, and X. Now, this is interesting because that could be any order. X could be the smallest, it could be the largest, it could be the middle. So I'm going to hold off on writing that down yet. It then says find the longest side of DEF. Well, if I'm looking for the longest side, that means X has to go here because that's my longest side that matches up, okay? Which means that 7.5 is my smallest and 12.5 is my middle. Now at this point, you have a choice. we're gonna set up our ratio, okay? I'm gonna put anything from A, B, C is gonna go on top, anything from D, E, F is gonna go on bottom. You can switch it up if you want to, that's totally up to you. The one I know I have to have is X. So X goes on bottom because it came from this one, and it pairs up with the other long side, which is 7. Now at this point, it doesn't matter which one I choose. You can pick whichever one you want. I'm probably gonna go with the smallest one because they have the smaller numbers, easier to use. So I'm gonna use these two, right here. Those are my smalls. This one goes with the top because it came from that one. This one goes with the bottom. It was down here, okay? We cross multiply. 3 times X is 3X. 7 times 7.5 is going to give us 7 times 7.5. I don't have my numbers here. Oh, well, that's fine, I'll do it. That's 49 plus another 3.5 is gonna be 52.5. We divide by 3, and that gives me X equals 17.5. Okay, so that's how much X is. Now, I'm not done because of this. Find the perimeter of DEF. Perimeter is the distance all the way around. We just found that this side was 17.5. So that means to get my perimeter, I'm going to do the following. I'm going to take 12.5 plus 7.5 plus 17.5. And I'm going to add those up. This gives me 20 plus 17.5. That's 37.5. That is my final answer for my perimeter of DEF. Okay? Moving on to our next one. Number 4. Again, if I'm moving too fast, you can always pause and go back. We got ourselves a picture. It says, assume the 2 triangles below are similar. So we have our right angle right here. We have a right angle right here. Now, when you look at an angle and the triangles are similar, that means this angle is going to be equal to this angle. So through angle, we're good. The 2 triangles are similar. But I put those there so that when I go to match up my sides, I know I'm matching up the right sides. They want to know, well, which one is closer to Juan? Okay, Juan or Alex, which one of them is closer to the flag? Okay, and how much closer is Juan? We know Juan is closer to the flag. They want to know how much closer. So that means I need this number right here, and I need this number right here. And then I'll subtract them to see how much closer Juan is, right? So ready, let's set up our equation, our proportion, right? So I know over here I need X. So I'm gonna take everything from Juan is gonna go on top, everything from Alex is gonna go on bottom. Juan, X is right here. X is the hypotenuse across the right angle. So I need the 14.4 to go right there, okay? The other 2 I'm gonna use is I'm gonna use the small numbers again, just because I have a choice. So I'm gonna use these guys, the 6 and the 8. So the 6 is from Juan, so that goes on top. The 8 is from Alex, it goes on bottom, okay? And then I'm gonna cross multiply, right? So I cross multiply, and I cross multiply. When I do that, I get 8x equals, and I'm cheating, I don't have the number. 8x equals, so 6 times 14 is 16 plus 24 is 84. So that's going to be 86.4. Sorry about that. I divide by 8. And I get x equals, in this case, grand total of 10.8. So that's my value for x. Now I'm not finished, because remember, we wanted to know how much closer is Juan to the flag. So we need to take the distance from Alex minus the distance from Juan, and that'll tell me how much closer Juan is. So Alex's distance is 14.4 minus Juan's distance, which is 10.8, okay? If you subtract those, you get a grand total of 3.6 feet. So Juan is 3.6 feet closer to the flag than Alex. Again, we just continue this same process. Draw the picture, label it, set up the proportion, solve. This one, a light post casts a shadow that is 15 feet long. So here's the post, here's the shadow, and it is 15 feet long all the way across. Sarah is 5 feet tall. This is Sarah, she's 5 feet tall, and she's standing 4 feet from the light post. So there's 4 feet from here to here, which means Sarah's shadow would be 15 minus 4. Sarah's shadow is 11 feet from there to there, okay? It wants to know how tall is the light post. So I'm gonna go post on top, oops, messed that up, sorry. Post over Sarah. Post, how tall is the post? Don't know. Post shadow, 15 feet. Sarah's height, 5. Sarah's shadow, 11 feet. Again, we cross multiply. I get 11x equals 75. I divide by 11, and I get x equals, drum roll, 6.8 feet. That's how tall the lamp post is, or the light post is. Not a very tall light post. But anyways, it doesn't matter, okay? Next one. No picture. So we're gonna make sure we read till we come to a period. They're similar triangles. So again, I'm gonna make myself a triangle ABC, a triangle DEF. A, B, C, D, E, F, okay? Triangle ABC has a right triangle with sides that are 5, 12, and 13. Now this time they told us it's a right triangle, so these are both right triangles. This is 5, this is 12, this is 13. It goes on and says, triangle DES also is a right triangle with sides that are 3.75x and 9.75. Find the middle side. So we're looking for this side right here. So that means this is 3.75, middle, and this one is 9.75. So we're gonna set up. Anything that comes from ABC is gonna go on top. Anything from DEF, I'm gonna put on bottom. Remember, you can always change that if you want to, it's totally up to you. I need to make sure I get this side. So I'm gonna take care of that one first. That one pairs up with the 12. So I'm gonna put 12 goes with X, right? Those are those two sides. I get to pick another two. I'm gonna pick the two smaller ones again. I'm gonna pick the 5 and the 3.75, okay? The 5 goes with the 12, it goes up here. 3.75 goes down here. We cross multiply, okay? 5 times x is 5x. This one's going to be 36 plus another 3/4, so that's going to be 12, 9? No. Yeah, 9. So it's going to be 36 plus 9 is going to be 45. Is that right? And double check my work. Yeah. Then we divide by 5. We divide by 5. We get x equals 9. So the missing side over here is 9. Okay. We got 2 left that we're going to do. Next one, you want to make a scale drawing of a large triangular sculpture with sides 3, 5, and 7.2. So we have a large triangle sculpture, 3, 5, 7.2. Listen, it doesn't have to be perfect, I get that. We're gonna do a scale drawing, okay? Now notice that my scale drawing, the shortest side is gonna be 0.1. That means I'm shrinking it. So I'm gonna make a little bit smaller one here, okay? Now, my drawing says that the shortest side of my new drawing is 0.1 feet. So that's gonna be down here. Because this is my shortest, that's my shortest. It wants to know what are the other two sides. Well, I need to find this side, so we'll call it X. I need to find this side, we'll call it Y. Which means I'm gonna have to do 2 different problems, right? We talked about this the other day. So let's start off with X. Anything from here is gonna go on top. Anything from here is gonna go on bottom. So I set up my first ratio. I put X up here. Oh, sorry, take that back. Didn't follow my own rule. X is gonna go on bottom. Anything from here is on bottom. X pairs up with the 5. So I put the 5 on top. 0.1 goes over here on the bottom, and that pairs up with 3. So I put 3 up on top. Okay? We cross multiply, and I get 3x equals 0.5. Okay? So now I'm going to take the 3x, and I'm going to divide this by 3, and I'm going to divide this by 3, and I'm going to get x equals 0.17. So that is my value for x. I now am going to do the exact same thing with y. Now here's a little hint. I don't want to use this number, so I'm going to leave it alone. I'm going to stick with the numbers they actually gave me to start off with. So I set up my second proportion. This time I want y. Y is on the bottom, goes on the bottom. Y pairs up with 7.2. I'm going to use that same one that I had both numbers for again. So the 0.1 goes on the bottom, and the 3 goes on top. And I cross multiply. And I get 3y equals 0.72 when I multiply by 0.1. Okay? I divide those both by 3, divide by 3, and I get y equals 0.24. And that is my answer for y. So notice I couldn't do them both at the same time. I had to actually 2 separate problems. One to find x, one to find y. And then last but not least, we have this one. By the way, nice little vocabulary word. It's called a trestle. A trestle is a bar you put across in a triangle to stabilize it, okay? So a bridge trestle is a triangular shaped with a support beam in the middle. So here's our trestle, support beam going across the middle. If the support beam is 38.5, so this is 38.5 feet long, how long is the bottom of the trestle? Well, they gave you some information over here, so we're looking for this one, okay? Now, we talked about this the other day, okay? We don't know if these lines are parallel, so we can't use our shortcut thing. So what we're gonna do is we're gonna take the small triangle to the big triangle. So before I do that, I notice that this is 50, this is 13. So if I take 50 minus 13 over here, I get 37. So this one right here is 37, okay? So now I'm gonna go small triangle to big triangle. So I'm gonna go small to big. Here's my ratio. Small triangle, bottom, 38.5. Big triangle, bottom, x. Small triangle, side, 37. Big triangle, side, 50. It's supposed to be a 5. And I'm going to cross multiply. So I cross multiply. I get 37x equals, I don't have the numbers, so it's going to be 192.5. Double check my work on that, but I believe that's right. So anyways, because 50, that's going to be 190 plus another 2.5, yeah, 192.5. I divide by 37. I divide by 37, that crosses off, and I get x equals 52, okay? That might be 1,925. Double check my work. Matter of fact, I'll do it real quick. You got time to watch me, you don't mind. Clear, let's go 37, what was that? Oh no, that was 38.5 times 50. Ooh, no decimal there. 1,925. So there's no decimal there. Okay, no decimal. Anyways, so we divide that, we get 52. So x equals 52. So this measurement right here would be 52 feet. Okay, hold tight. All right, we're going to jump over to the next page, and I'm going to do one more. Just going to randomly pick one. Let's go with. Let's go this one, number 5. So number 5 over here says the two hills have similar area. If Cora takes the long way down, how far will she travel? Well, you guys, if they have a similar area or a similar volume, that means their measurements have to be similar as well. Okay, so how far will it be if Cora takes the long way down? Okay, Now, we don't know what the long way down is going to be for these two, but I have to assume that this is the long way because that's the only one we don't have a value for. But you got to be careful on this one. It says they're similar triangles, okay? So we've got Cora over Anna. So anything from here is going to go on top, anything from here is going to go on bottom, right? So I'm going to set up my proportion. Here's where you got to be careful. It goes small, right, side, medium side, bottom. So this is going to be small, medium, bottom. So I can go bottom to bottom pretty easily because that's going to be easy to set up. So Cora, she's 40, Anna, 70. Now I need this side for Cora. That's X. But remember, Cora's looking for the long way down, right? She wants to take the long way down. So if this is her long way down, I got to pair up with Anna's long way down. And Anna's long way down is 68, okay? These are the base of the mountains. That's her long way down. So then I'm going to cross multiply. I'm going to get 70x. Let's see if I actually work this one out. 70x. No, I did not. So let me get my calculator. I should have worked it out ahead of time, huh? You guys like Mr. Myers, you're not prepared. Okay. Right. So I'm going to go clear, and I'm going to go 40 times 68 equals 2720. I'm going to divide by 70, okay? And when I divide that by 70, I get 38.86. So it'll be 38.9 feet. That is going to be Cora's long way down, okay? Again, we have to make sure throughout this whole thing, you are pairing up the sides with the correct sides, okay? All right, I'm gonna stop there. You guys need to go to your EDIA, check out the EDIA, and do your best on it, and I'll see you tomorrow.